V49 begins on slide 7 and introduces our next unit of probability. So probability is expressed by a fraction, which represents the number of favorable outcomes over the total number of possible outcomes. So if we were to express the probability of getting a tails on flipping a coin, there's only one tail, so that's your favorable outcome. So it's going to be a 1 over the total number of possible outcomes. There's a head and a tail, so that's 2. So the probability of getting a tail is 1 over 2, or 1/2, or 50%, or 0.5. So slide 9 demonstrates this, flipping a nickel and landing on a heads. So the possible outcomes are going to be a head or a tails, and the favorable outcome is going to be a head. So putting it together, it's 1 out of 2. And slide 10 shows you that probability can be expressed in more than one form. So if we think back to fraction, decimal, and percent, fraction is 1/2, decimal is 0.5, percent is 50%, and even a ratio, the ratio of 1 to 2. So let's say the probability of randomly selecting a blue marble, if there's 6 total marbles, one of them is blue, so the probability as a fraction would be 1/6. The probability of a ratio would be 1 to 6. The probability of a percent would be 16 7/10%. And finally, the probability expressed as a decimal would be 0.167, or 167 thousandths. They all represent the same probability, the same value. Slide 11 shows that probability occurs between 0 and 1, where if the probability of something happening is 0, that means that it's impossible, it's never going to happen. And the probability of a 1 means that it's absolutely certain that that outcome is going to happen. And then it becomes a scale from 0 to 1. So anything, if I split this up from 0 to 1, it should be 1/4, 1/2, and 3/4. So anything that's between 0 and 1/4 is going to be unlikely. And even going up to just below 1/2, that's all, this whole range is unlikely. When it's exactly 1/2 or 50%, you call the events equally likely. So for example, flipping a head on a coin is equally likely because its percent or its probability is at a 50%. And then when I cross into anything above 1/2 and get closer to 3/4, that means that something is likely to happen. So basically anything below 1/2 that's not 0 is called unlikely, and anything above 1/2 that's not 1 is called likely. So it's less likely for something to happen, it's going to have a smaller fraction, and more likely will have a larger fraction closer to 1. So slide 13 is a very important note. The sum of all possible outcomes is always equal to 1. So if we break this down in a simpler example, the probability of getting a head on a coin is 1 out of 2. The probability of getting a tail on a coin is 1 out of 2. So 1/2 plus 1/2 equals 1 whole, 2 out of 2, which is equivalent to 1 whole. So here's a little bit more complicated example. If there's 3 choices of jelly beans, grape, cherry, and orange, the probability of getting a grape is 3/10, and the probability of getting cherry is 1/5. So I want to know the probability of getting an orange. Well, I know if I add up all 3, grape, cherry, and orange, I get 1. So I have to add 3/10 and 1/5. 1/5 is equivalent to 2/10. So 3/10 plus 2/10 is 5/10. And then that leaves me with my unknown orange. So 5/10 plus how many tenths gives me 1? 5/10 plus 5/10 is 10 out of 10, which is 1 whole. So the probability of getting an orange jelly bean is 5. Actually, it should be 5/10 or 1/2 because there's 5 orange jelly beans out of 10, which is 1/2. Slide 14 gives an example with letters. So Arthur wrote each letter of his name on a separate card and put the cards in a bag. What is the probability of drawing an A from the bag? Well, remember, probability is what you want, favorable outcomes, over what you have, which is the total possible outcomes. So if I have Arthur, that's 1, 2, 3, 4, 5, 6 is going to be the denominator. And I want an A, so there's only one A in Arthur, so therefore the probability of drawing an A from the bag is 1 out of 6. So 1A out of 6 total letters, the answer would be letter B. Please go ahead and pause and complete numbers 15 through 17 on your own. So slide 18 asks what the probability of rolling a composite number on a fair number cube. A fair number cube is just talking about a die, 1 through 6. So we need to figure out what a composite number is. So if you want to jot this down on slide 18, it will help you. Knowing what a composite number is important in many problems to come. So composite is an integer that's greater than 1. Remember, an integer is a whole number, 0, and all of the whole opposites in the negatives. A composite number has to have more than one divisor other than 1. So take, for example, number 1. 1 can only be divided by 1, and it doesn't have any other divisor, so it's not composite. So in other words, a composite number is any integer greater than 1 that is not prime. So 1 is not composite. 2 is only divisible by 1, so that's not composite. 3 is only divisible by 1, so that's not composite. 4 has 1 and another divisor other than 1, so that's composite. 5 is only divisible by 1, it's not composite. And 6 is divisible by more than 1. So you have 2 composite numbers. Go ahead and finish writing the probability of rolling a composite on a fair number cube. Please pause and finish number 19, the probability of rolling a 7. When you're finished, this is the end of v49. At the bottom, please write how many school days there are until the last day of school. If you get this correct, I'll give you a ticket in school tomorrow.